Just welding over all this slag. Just don't feel right. Feel like I'm making soup. Ugh. What a blob. Welcome into another episode of Weld.com, everyone. I know how much you love us talking about all those plugs in all of our episodes, but today that's all it's going to be about. Plugs and slot welds. Let's talk about it. Now, before we dive into the weld symbols on plugs and slot welds and some examples of those as well, and go over some more weld symbols with those examples, let's answer a few of those questions that you might have about these things. First of all, what the heck is a plug or a slot weld in the first place? Almost always, it's two pieces of metal either on top of each other, stacked, or overlapping, and one of those members of metal either has a hole in it or a slot. Most of those times it's because they want to attach those two pieces of metal without weld on the side being in the way, or maybe it's for aesthetics, or maybe it's for mechanical purposes. The weld needs to be filled in those holes in order to attach those two pieces of metal. Is a plug weld as strong as a spot weld? Because they look very similar. The biggest difference between these two is a plug weld has, again, that hole in it to attach those two pieces of metal, and you'll weld through that hole. And I would say that's a pretty strong freaking weld. With a spot weld, you're going to be doing a weld without that hole there, and it's going to be forcing that arc through that first plate and into the second, hopefully penetrating it. And it is still a stinking strong weld. Typically not always done with the same processes, and I would say spot welds are more used on thinner sections of metal. They're great for sheet metal work, and not usually used for MIG or flux core. It's usually like a TIG or a laser or a resistance beam welding process in order to do a spot weld. We don't want to get them confused. I would say plug welds are probably a little stronger in the fact that we're kind of getting that other variable, that other piece of metal out of the way and already skipping a step and getting to that second piece. You're not going to see a whole lot of spot welds on thicker joints of metal, whereas plug welds really succeed on thicker joints of metal. How big of a hole do you make in the first place? That's not up to you. As a welder, you're going to be looking at the blueprint, right? That is what you're supposed to be focused on, and you're going to follow that to the T. If you're on your own and you don't know any better, I would say double your material thickness. So if you're doing 1/4 inch plate, definitely need at least a 1/2 inch hole so that you have a really strong weld joint. I would say no less than like 5/16 or 3/8 if you're getting down into thinner sections of metal. You still want, even though you might be working on 1/16 of an inch material, you can use an 1/8 inch hole. I still recommend a bigger hole because, again, it's just a bigger weld joint. The last question that we have is how that hole is typically made. You can make the hole with anything you want. You can drill it, you can punch it out with an iron worker, you can cut it out with a torch, you can plasma cut it, you can laser cut it, but you have to be aware you're going to have to weld in that hole. So you're going to need to prep that hole if you're using a process like plasma or oxyfuel. Now that we know a little bit more about plugs and slot welds, let's dive into the weld symbols. So let's talk a little bit about weld symbols. If you want to learn more about weld symbols that are just more than just the plug or slot welds here on today's episode, you can go to the American Welding program. We've partnered up with them. There's tons of content with the AWP, and you can take these weld symbol courses that'll really help you kind of fine-tune either the skills that you already had, and maybe you need a refresher. You can just purchase either the book or you can take the course on its own. So I really think schools are kind of putting it all on the students to learn these weld symbols on their own, and it's really tough to learn whenever you don't have someone teaching it to you and all you're doing is reading out a book. So hopefully we can do something for you today. These are our spot and seam welds. Of course, we didn't want to get these confused earlier, but this is what those will look like. So if you see those, that's not a plug, not a slot, that's a spot and a seam. We don't want to talk about these today. The other things you'll see is you'll see a lot of lines on here. Some of them are dotted. You have your object lines and your hidden lines. So your object line is a line when you're looking at the plate from either your top view or your side view. It's a hard, solid line. You're going to physically see it, whereas these dotted lines, they're in there, but they're being blocked by a part of some sort. So they're going to usually show up as these hidden lines. A plug weld is going to be this little square. So is going to be the slot. Those are going to be your plug and slot welds. Now there's going to be a couple differences in how you figure out which one's a plug and which one's a slot. One, by looking at the picture, and two, by looking at a little bit of the information that's in it. For the left side of a plug, you'll have the hole size here. Whatever size hole will be there, say it's 3/4, you put a 3/4 inch size hole. Right here, if it says 3/4, that's going to be the width of your slot from edge to edge, because we don't necessarily have a hole anymore, we have an elongated hole. Now on the right side, we have the distance apart. You're going to see this as just one number as a measurement, right? 1.5. So if it says 1.5, then these will be 1.5 center to center. Now, as far as these two dimensions underneath, we can have a chamfer on those holes or on these slots. A chamfer for a countersink for the holes, or maybe you have a little bit of a bevel in order to make a better weld, whatever it may be. They're going to put the degree on it, almost making it like a V groove or a groove on either side of the holes and the slots. And then the reference number at the bottom of these will be the number of holes or slots on the part itself. So here we'll have 4, so that number would be 4. If there's any type of number in here, it'll tell you the depth of fill for that hole. Same thing with the slots, is your depth for the hole. If there is no number there, you're going to fill it up all the way. The biggest difference between a plug and a slot is the fact that when we have a length and a pitch, because now we have a width here, but we also have the length of the weld and from center to center of each one of those. So say if this is 4 inches, this is a 4 inch right here, we would put 4-8 inches center on center, so it'll be 4-8. That's a little bit about the weld symbols themselves. If you looked at them from a side view, again, you can see this hidden line. The goal of all the welds that we're doing today is to come in this hole here and fill in and tie in to the bottom and then make our way up all the way and flush things off. There will even be a time when they might put a contour symbol, a convex or a flush contour, well, they'll say, hey, I need you to grind that flat. It's really nice because you won't even see that there's a weld there. Now that we know a little bit more about these weld symbols, let's go over some demonstrations here on my weld table. Now, as far as what welding process do you use, you could use probably anything. As far as D11 structural welding code goes, it's usually stick welding, flux core, MIG welding, spray or pulse MIG welding is what they'll typically specify. Today, we're going to be using the ESAB Rebel EMP 285 IC. We've got some 035 MIG wire running through our Abacore Benzel torch here. And then once we do a couple MIG welding demos, I want to see some flux action, some flux in the actual hole itself. We're going to switch over to some 71 Ultra, some 045 flux core, and then I plan on taking the head off of this thing and swapping it over to my 045 tip. With this Abacore Benzel torch, they're really nice because you can take these off and change them out to goosenecks, straight ones, long ones, short radius ones, anything that you want, any direction you want. Even if you want to be a weirdo and weld with your thumb, you can do that. Let's look at the first one, which is, some sheet metal. Let's take a look at our first weld joint here. We got a lap joint, 2 pieces of metal, one overlapping the other, and a bunch of holes in the top. This is some 16 gauge material, so 1/8 of an inch hole, like I said before, you might think is the rule of thumb, but let's try to shoot for at least 5/16 as the hole size. For here, the hole size is going to specify on the weld symbol as 1/4 of an inch. And again, I measured these and used a 1/4 inch drill bit to get that hole on there. And then we have 7 holes. So again, that number at the bottom of the plug weld symbol is the number of holes. And then to the right of it, we have the spacing. So between each hole, we should have 1.5 inches. That's your weld symbol for this one here. And because there's no depth of fill, it'd be really hard to not get anything but full on here. We're just gonna fill those in. Again, for sheet metal, this is a really nice way of fastening material, and then of course you can blend those off. If you take that contour and say we want that flush contour, we can go ahead and flatten all those up, and you almost have a nice weldless looking seam. I would say for most sheet metal plug welds that I would do, I'm going to start right in the middle and let that thing just wash out really hot. Just welding hotter than I would normally, just so we know we tie into everything and we get the root all the way around. And there we have it. We have our plug welds here. You can see that little dot in the middle. I probably could have held the trigger just a little bit longer to make sure to not have that, because if we were to finish this off, we don't want to see a low spot in the middle of that. This would be a nice way to finish something off, especially for sheet metal. Instead of like putting a weld right here on the seam where that metal would want to kind of pull this side would want to pull up, or if you did it on the other side, vice versa, or if you did it on both sides, they're both kind of fighting against each other. Whereas these plug welds, it's just squishing things together. So it's a really good method for sheet metal. And of course you can see the evidence here of the penetration all the way across. That is a very solid weld joint. It's never coming apart. Now we can move into some thicker stuff. I've got some 3/8 plate here. Let's take a little look at my made up part here. We're going to ignore these 5 holes right here. These are going to be some examples for what we're going to do next. But if we look at our weld symbol here, we have a plug weld or slot weld symbol. We see that it's 4x16, so we know that it's a 4-inch long slot by 16 inches center to center. Again, ignoring these two, the 3/4 again is the width of this slot, and we have 2 of them. The depth of fill is all the way up, so we would fill this all the way up. I'm going to probably start it off to show you the root pass and then the fill and show you exactly how far we need to get up. Because in section 5.24 of D11, it actually has the techniques to use for your plugs and slot welds. And it says to do the root pass first, And you're able to sit here and weld and weld and weld and weld until it's all the way full, even on something that's 3/8 thickness, without stopping. As long as you're able to get that root pass all the way around first, and then fill in the middle, and then just keep doing it in a spiral pattern. And as far as if there's slag involved, if you're welding flat, you can do the same thing. You can sit there and weld and weld and weld without stopping, because if you have the right settings with a good, nice, clean wire, you should be fine. Now, if you're talking about other positions like a vertical or overhead, you should probably stop and chip the slag. I would do that anyway. I would do the root pass if I was using, say, sticker flux core, and then clean the slag up, and then do the next layer and clean the slag up. It's just kind of more reassurance and not trying to cut corners, even though the code says I can sit here and weld and weld and weld. For 3/8, it probably isn't going to be an issue, but I've got some thicker metal. I want to try that out later and see if we trap any. But for now, let's go through putting a root pass in a plug weld. I would say maybe start a little bit towards the center and then push out to that side real quick. You're going to want to look right down at this old dog as you put it in. I don't know if I'm going to get a good arc shot of this or not, guys. A little crunchy. Maybe I'll turn up my volts a little bit, just one. Maybe we'll see a little bit more on this slot weld how it goes. So I've already taken the liberty in buffing this off. Code does say if you stop welding, you need to try to clean it. Now, it's hard to get into some certain spots on these deals, so you'll probably have to get a die grinder out, some sort of bit that cleans up those spots. Now, if you don't stop welding, like what we're going to do on this one here, you just fill it right up. But you want to get that root of it, get to the center, and we're just going to keep doing circles and circles and circles until it fills right up. This one got our root in, but we probably only got about halfway. So if the code said to go only 3/8 of an inch, that'd be pretty much there. Same thing with this. For these other ones here, we're going to fill this one up, and then we're going to switch to flux core and do this hole over here and fill this one up all the way. And then for these little holes, I want to put a couple welds in there just to see if I can get to the root of the problem. I don't know if I'm going to be able to cut and see the evidence of actually tying into the root well or not, but we might get to that point. Yeah, it filled up so quick. Got to the center of it. It probably did not get to the corners of it. I bet that looks way different than this one that we're gonna do here. And I'm just gonna keep doing that circle, really letting my puddle stay super hot. I don't want to build up into the middle of it, because the middle is kind of taking care of itself, and that'll be where I finish things up. Right in here, spending some time in the middle, get around those edges. Got such a molten pool right now. Yeah, that's a hot sucker right there. Now that we kind of see the difference between halfway up, all the way up, now let's switch over to flux core, see what those look like. And I've even got some thicker plate to weld on. With even too small of a hole, we might just check that one to see if we trap anything. So we've gone ahead and switched over the machine. I clipped my MIG wire out.
No! No! God, please, no! No! No!
Pulled that spool out. It was no good to me anymore, and we went ahead and changed out our drive rollers as well, because we want to switch over to some knurled rollers, and this is a bigger sized wire, so we went ahead and switched that over, ran it through our Abby MIG gun, and I did go ahead and swap out the gun head, mainly because this has all of my bigger consumables like the nozzle, the contact tip on it. That's just what I have set up. I could have easily just as much changed the contact tip and some of the other things. The big thing is this nozzle didn't fit on that other gun, so I wanted the bigger nozzle, so I needed this head. Anyway, what we're going to do here is we're going to weld the root of this side first with flux core, and then we're going to fill these two guys in. Now this one, again, because that hole size is smaller, I'm assuming I'm not going to be able to get to the real root of it. This one we'll be able to fill up all the way. This one we're going to basically fill up halfway, or just get the root in so you can see what that looks like, and we're not going to stop welding on this one. So let's go ahead and get to it. I don't think I turned the gas on, so I better do that before I light up. Alright, yeah, now we got that sauce. I don't know, that one might have been hotter than that MIG we did. Let's do the big hole. You can go counterclockwise or clockwise, but we're going to look straight down at this guy. Yeah, we should be allowed to keep welding even with that slag there, as long as our settings are appropriate. And we'll find out when we cut this open. Hopefully we can get it cut open. Give these a quick jimmy. Oh yeah. I don't know if I even got that whole hole. I couldn't see a lot because that slag was in the way, so if I had to say anything about it, I might even fill that up more if I had to blend that down, or if the code required it to be flush. We're still not quite even, a little bit under there. This is a little bit under all the way, like in the center, that's kind of concave. I think we don't need to touch them just for experiment's sake. We're going to go ahead and put the root pass in here so we can get a good look at what that looks like compared to like this MIG weld. Trying to keep a drag angle. I'm just going to run right through the middle of that slag. And we got that root pass, first pass in. So if it were me and I was actually doing this for an actual job, I would do my damnedest after each pass to get all that slag out. Now again, the code says you don't have to if you don't stop. I would say one of the #1 killers of good welders is complacency. You get too comfortable doing the same thing over and over again, you start trying to cut corners, and then you get those repairs or those failed x-rays or whatever they may be. So what we're going to do now is just continue with this slot weld because we haven't seen one filled all the way up. I'm going to chip the slag each layer. I figure it'll probably take me at least 3-4 more passes to get this thing above flush. Now that I'm fairly certain that I've got the root of everything, I don't think I need to be on top of it like I was just eating all that smoke. I could probably stay out of it a little bit more. We're going to keep that same counterclockwise. We're not going to try to weave anything. We're going to just do our stringer beads in that circle and going right back up the middle. Now that we were able to get that slot weld filled in all the way, nice and flush, spotted up a couple places, it looks great. It was a great way to show how to hide a slot or a plug weld, and a good way to showcase those 3M Cubitron 3s, those fiber discs, one of my favorite ways to take down a weld. And what I want to do next, I'm going to probably cut the majority of these slots off because I want to focus on these plug welds. I want to cut into them. I don't know about necessarily a cross-sectional etch, but I do want to see if we were able to get complete fusion. And we're going to do one more weld before we get to that point. I've got a piece of 1-inch plate right over here with an 1.5-inch hole, so the hole diameter isn't double the thickness of the plate. It's 1.5 inches, not 2 inches. So what I'm going to do is I'm going to take this flux core and just fill it, stir that pot, and just see if we do trap any slag, and then we're going to get cut crazy on these plates. Alright, we got the 1-inch plate in front of us. Make sure we get that root of the problem fixed first, and then we're going to just keep spiraling and spiraling around. Ooh, it's deep. Narrow. I'm going to be here for a second. Just welding over all this slag. Just don't feel right. Yeah, it just feels like I'm not gonna have success with this thick of a weld. I feel like I'm making soup. Oh, I just don't believe it's gonna be good. Ugh. What a blob. Get the slag off first. That all came off good. So just taking down the surface of it, I would say that's some trapped slag right there. Yeah, that's definitely slag. That's a little piece. I wonder just how bad it is in there. All right, take all this off. Let's get the cutoff wheels going. It's gonna suck. with 4.5-inch cutoff wheels. We were able to get through that 1-inch plate, and we've got a ton of evidence of some trapped slag. I'm going to clean that up a little bit more with the fiber disc, but first I want to make this a little bit smaller and try to see the cross-sectional of these plug welds. I would say this is not the normal way that people will go about looking at plug welds. Non-destructively, you can get the surface stuff with some PT, but if you wanted to see inside, you probably use something along the lines of ultrasound. Maybe x-ray, but I probably would say they'll probably stick with some ultrasound with this type of stuff. I'm just gonna see about where I need to cut. I'm gonna whip out the old Thermocut Extra Fire 85 HD, give it 65 amps to the tip here. All right, you're gonna cut it there and there. Oh, you gotta put the ground on that old dog. If you're set to 65 amps and you go to hit that plasma and it does nothing, there's a good chance that you don't have your ground on.
Now this is 3/8, and then we're going to be adding on to getting about 3/4 of an inch thick with that stacked piece of material. And that's why I wanted to whip out the old plasma cutter.
Because I did not feel like doing that by hand. And that's why you bring a plasma to a grinder fight. Clear as day, straight cut through both pieces, no problem. And now what we're gonna do is try to cut just the face of these plug welds off so that I can clean it up and hopefully see if we got penetration all the way down to the root. We'll take a closer look at that one in just a second. Let's clean up this 1-inch plate. Good God, that's full of slag. I think my favorite thing about a fiber disc is the fact that it can take away so much metal so quick, but it doesn't put all the dust and smoke in the air. It makes swarf, which is like metal, small, fine metal shavings that are heavy enough to just sink to the ground. And now that we've got the face of everything cleaned up with that fiber disc, we can see everything a little bit clearer now. 1-inch plate with the 1.5-inch hole trapped a ton of slag. Maybe that rule of thumb, that hole being too small, being 1/2 inch smaller than the recommended 2-inch hole size for that plug weld, for that thickness of metal, maybe that was the issue. I would say we probably were on the range of a too cold of voltage and too low of amperage in order to make this continuous weld. But if you were to take it in stages, you would not see this. This is the definition of trapped slag. That is just crazy how much slag that's in there. Trapped slag is a big issue, even though it looks kind of solid and it's not really coming out of there too much. It's kind of chipping out. If I stay steady at it, we're going to basically have ourselves a cavity. It's different shapes and sizes, but they almost always have a sharp edge to them somewhere, or a corner. And what corners usually do is they add stress to that material. A stress riser typically forms cracks, and cracks are bad. Cracks you do not want. So slag, you do not want. You want a nice sound weld throughout. Going into this other plate that we did, we have a lot of sound weld on these two bigger holes. We got the flux core welds right here, and then the MIG welds right here. This was the bigger hole for the flux core. And we have nice sound fusion all the way throughout. Don't see any issues on the plug weld itself. Nothing to cry home to mom about. Now when it comes to this little weld right here, that too small a hole, we didn't have enough space to get down there in time to get to those corners, so we can see clear as day trapped slag and lack of fusion in the corners of our plug weld. That's why it's important to have enough space and get that weld pool started enough, hit the root first, so that we can make sure we get fusion all the way around. Moving out of the slaggy process, right, flux core going to MIG, hardwire, we have a nice smooth sound weld right here on the big hole. On the little hole, we don't see any of that, the corners of the trapped slag on here. And at first glance, you're like, oh, that was probably just works better. But if you put it in the right light, just kind of shine it around a little bit, we have two clear as day lines of lack of fusion, where again, we did not get down to the root of the issue and get the root finished before filling up. Just not enough space. So we didn't get the fusion. This probably wouldn't be the way that they go about finding that evidence. They'll probably use some form of non-destructive testing in order to find it, like ultrasound or maybe x-ray. Let us know in your experience, how do they go about testing, whether it be destructive or non-destructive, plugs and slot welds? We'd like to know. Thanks for tuning in. As always, everyone, before you leave, check the links down below from the cool gear that we wear, like Ariat FR, Outlaw leather, Cayman gloves, as well as the equipment we use today, like our 3M abrasives for all the types of grinding we did, and the ESAB EMP Rebel 285. More information on those things are down in the links below. Again, thanks for watching. We'll see you all in the next weld. Take a peep at our first weld joint here. We've got some, I think this is some 16 gauge material. So if we're going by the rule of thumb of doubling it, we want to at least have, what is that? That's not 16. Is it 16? No, that's, I gotta measure it.
I should have already done this, right?
I need you to go back into the house, dog. You do not need to be in here. I know it's thundery and you're scared, but you have to go inside. Inside is better than in here where I'm about to drop a bunch of molten blobs.